Okay, so last week I showed you how you can save the cycle time we have saved here. So now if I am happy with these results, let me accept this, and what happens is it's applied a feed rate, and you can see the feed rate bar is not displaying the feed rate, but it's showing all these are optimized. So let's go to float from solid, and you can see here how exactly it has optimized. So we put a maximum air grinding feed rate of 1000, maximum feed rate of 400, and as it approaches and when the material removal rate is low, it's going at a much higher feed rate, and then as it comes into the floats, it's coming at much slower feed rates, and then as it exiting the tool, it's going out at a higher feed rate because the material removal is less, and then it is actually going at the maximum feed rate. And this is exactly how from the end of tool you are coming in and then you are dropping it, and then this is how the feed rate is optimized, and this is where we get the cycle time from. And if I simulate this tool now, let's see how the graph changes and how this evens out. And now you can see how this is actually, rather than a slow steep material removal rate, it's actually calculating that with the feed rate, it's making sure that it's done right, and this is where all your cycle time saving comes in.